Hi, thank you for being in front of the screen. This is Fender Lin from National Cheng Kung University. Today, I'm going to share our research about ConTrans, a two-stage concentric annealing approach for multi-criteria distributed competitive stationary resource searching. The problem of demand inference for stationary resource along with the constraint route planning with multiple criteria that guides mobile agents to a resource has long been a crucial issue. Precisely, the problem of mobile agents searching for a stationary resource has appeared in applications such as travelers in vehicles looking for on-street parking slots, taxi cabs searching for customers without a reservation, and scheduling for violation fine collection or waste collection. Generally, such stationary resource searching can be categorized into two governance models, centralized one or distributed one. The difference between these two models is based on whether there is a role of dispatcher, who retains the accessibility of information and jurisdiction over all the vehicles. One common example for a distributed model is that vehicles can only cruise without any information about resource until they come across something available, and the exact location or intention of other vehicles are partially or totally inaccessible. On the other hand, under a centralized model, there could be a dispatcher who handles all the information and allocation of vehicles in a taxi fleet or a mass transit. Consequently, we focus on the multi-criteria distributed competitive route planning for parking slot cruising in zero information region. The zero information region here means that there is no parking sensor coverage within the searching region, which is also one of the most common situations in urban transportation. Thus, the first challenge is that neither real-time nor historical availability of parking slots in the area is accessible. And another difficulty lies in the route planning on the distributed governance model with limited knowledge toward these crucial information. For the problem, given parking slots and mobile agents with their initial location, targeted destination, and preference for time consumption between cruising for parking space and walking from parking slots toward the destination. The goal is to guide each vehicle without a centralized authority so as to minimize the weighted time consumption of vehicles and maximize the parking slots utilization. Precisely, the first optimization criterion for our problem is a combination of searching time and walking time according to the vehicle's preference, while the second criterion for resource utilization could be interpreted as the success rate of vehicles, which also represents the social welfare. Meanwhile, apart from the targeted mobile agents, another group of agents is introduced as the shuttle vehicle, and these shuttle vehicles can directly occupy or vacate certain parking slots based on historical data to represent the exact demand for resource at certain time during the simulation, or to imitate the irrational attitude for agents so as to append such uncertainty to the environment. The proposed method consists of two parts: inference for parking slot availability and route planning for mobile agents. First of all, we adopt the grid-based feature engineering to store heterogeneous urban data as the input features for the inference model. Next, based on these urban information, a special temporal availability inference model can be used to infer the probability of parking slots being unoccupied, with neither historical nor real-time availability sensor data in the region as the input. With the results from the inference model, we propose a two-stage route planning algorithm named ConTrans. Our proposed algorithm combines a destination priority guiding and the concentric annealing with orbital transition. Precisely, contrans is inspired by the concept of preclustering and the confirmation of energy levels. In the first stage, it relaxes the loading of outer regions with relatively few destinations. After the agent reaches the pre-computed boundary orbital, the second stage policies are triggered to instruct the agents on a concentric basis. Accordingly, it can suggest a route for each mobile agent that maximizes not only its own searching experience, but also the resource utilization. We use two real-world parking slot datasets with different road network structure from San Francisco and Melbourne, then further divide each city into 3 regions with distinct urban functionalities. Meanwhile, most of the urban features for the inference model are retrieved from Google Map, OpenStreetMap, or government's open data platform. As the first part of the evaluation, the parking slot availability inference takes the mean square error as the evaluation metric. And based on 4 tested regions, DNR seems to be more stable. However, other state-of-the-art inference methods could still be used to replace the adopted DNR. Furthermore, ablation study for DNR shows that combining these urban features can help to make the estimation more accurate, and features related to population have the best performance given single urban characteristic being considered. Next, for parking slot cruising, the evaluation metric includes weighted time consumption for cruising experience and success rate for resource utilization. The first one is to be minimized while the latter is to be maximized. Finally, we randomly generate around 60,000 testing cases for 6 regions under different constraint settings, such as amounts of mobile agents, candidate destinations, and preference. First of all, we illustrate the results of each method in ratio over our constraints under different amounts of agents and frame the performance under the maximum amount of agents in black, while minimum in gray. Accordingly, our constraints can achieve Pareto optimal between searching experience and resource utilization in most regions. Although constraints does fail to retain the best performance in cruising time and walking time among state-of-the-art methods, it still maintains the success rate at around 97% in San Francisco dataset and 100% in Melbourne dataset, which clearly outperforms other methods for the stability. Furthermore, the results for each method on the different amounts of agents show that constraints has a significant increase in cruising time with a steep decline in success rate when the amount of agents is increased in some region from San Francisco. We believe that this is due to the limited amount of parking slots in that area. For instance, given around 200 parking slots in FW region and the occupancy of shadow vehicles, there could be no available parking slots, and the success rate for all methods might be limited even in a centralized model. To sum up, our constraints has decent performance in cruising searching time and retains the best stability in both searching experience and resource utilization under different amounts of mobile agents. On the other hand, under different numbers of candidate destinations, it seems that the cruising time for especially PG and DP methods are less stable. due to the non-monotonic effect of the exact location of destinations and the connectivity of road network structure. Meanwhile, all methods show a clear decline in working time as the amount of destinations increases in San Francisco dataset. However, this tendency is not so notable for Melbourne dataset. We believe that this may be affected by the road network structure in Melbourne, where there are more roundabouts, alleys, and cul-de-sacs, with the parking slots not being simply placed on both sides of the street. For searching experience, since TS methods synergize DP and TG methods, its success rate is more sensitive and goes in an unfavorable way compared to our constraints. On the contrary, our constraints across the most stable results in 6 regions from 2 datasets. To conclude, we focus on the problem of multi-criteria distributed stationary resource searching and formulates its application of parking slots cruising in regions without sensor coverage. Furthermore, comprehensive evaluation and simulation for on-street parking in 6 regions from San Francisco and Melbourne datasets show the effectiveness and adaptability of the proposed inference method and constraints algorithm. Future work include adopting other state-of-the-art inference methods, additional datasets, or real-time traffic simulation, applying real-time information on the constraints, and considering other urban features to further improve the agent's cruising working time performance. Thank you for your patience, and if there are any questions, please feel free to send me an email. Thank you.